Russia is ready to dominate the world with its unrivaled military technologies. From its powerful and lethal air fighters to its sea behemoths, this country is definitely one of the most powerful in the world, a force to reckon with. However, Russia is not planning to relent and has continued to shock the world with its military capabilities. With an investment of over $750 million, Russia has created the ultimate weapon whose sheer capability has surprised the world even more. What are the capabilities of this fighter jet? Is it truly equipped with features that makes it unrivaled, even by the United States? Join us as we delve into the features of Russia's $750 million fighter jet that has sent lethal shockwaves across the globe. Beginning with the sixth-generation aircraft, it is general knowledge that several nations across the world have begun the development of their next generation of fighter jets. However, one question has remained constantly on the mind of people that are aware of the excitement surrounding the creation of these sixth-generation fighters. What exactly is so special about them? A sixth-generation fighter is a new type of jet fighter that is more advanced than the current fifth-generation fighters and even previous generation. Countries like the United States, Russia, and China are working on their own sixth-generation fighter programs. Meanwhile, countries like Japan, Italy, the United Kingdom, France, Germany, and Spain are teaming up to share the development costs. These new fighters are expected to be ready for service in the 2030s. Though still in the early development stages, several key features have emerged for sixth-generation fighter concepts. These new fighters must build on the fifth-generation abilities in air-to-air combat, battlefield survivability in challenging environments, and ground support/attack, adapting them to future threats. The focus has shifted from close-in dogfighting, now less common, to broader roles including ground support, cyber warfare, and even space warfare, while maintaining the importance of beyond visual range missile capability. These fighters are expected to handle both manned and unmanned missions, integrating with extensive networks of satellite drones and ground sensors to provide comprehensive data-to-decision capabilities. The design characteristics expected to meet these demands include advanced digital engineering, high-capacity networking, AI, data fusion, and cyber warfare capabilities. They will likely be optionally manned, with airframes capable of piloted, remote-controlled, or onboard AI-controlled missions. Enhanced human systems integration will feature virtual cockpits with helmet-mounted displays offering 360-degree vision and AI-enhanced battlefield awareness, replacing traditional instruments. These fighters will also have advanced stealth airframes and avionics, variable cycle engines for efficient cruising and high thrust, increased range standoff and BVR weapons, and possibly directed energy weapons like laser CIWs. A separated software architecture for flight-critical operations and the use of Joyan transistors are also anticipated. However, the feasibility of these features is still uncertain, with development time and costs likely to be major factors. Specific requirements are expected to become clearer around 2025. But let's focus more on Russia's sixth-generation fighter jet and the mind-blowing features it is equipped with. On August 26, 2013, Russia announced it would start developing a sixth-generation jet fighter, which will probably be pilotless. However, they will not stop working on their fifth-generation fighter projects, like the Sukhoi Su-57. The Mikoyan PAK-DP is a Russian program to create a new interceptor aircraft to replace the Mikoyan MiG-31. Russian defense analyst Vasily Kashin says this aircraft could be seen as a 5++ or sixth-generation fighter project. In January 2021, Rostec Corporation, which owns Mikoyan, announced that the PAK-DP had entered the development phase, stating that the development of the next generation of interceptor fighters has already begun. This sixth-generation fighter, also called the MiG-41, is planned to replace the MiG-31, featuring advanced stealth design, avionics, and variable cycle engines. The jet is expected to reach speeds over Mach 4 and have features like anti-missile lasers and near-space flight capabilities. However, there is skepticism because Russia has had difficulties mass-producing fifth-generation jets, and this project is very ambitious. The MiG-41 will use an upgraded Saturn AL-51 engine for better thrust and performance. The new engine will have a 19% higher thrust-to-weight ratio than its predecessor, with an estimated thrust of 37,500 pounds when using afterburners. Besides the Su-57 and PAC-DP, the Saturn AL-51 will likely be used in the upcoming Su-75 Checkmate light tactical fighter. The Russians are in a race with the Americans to develop a sixth-generation fighter. Since the Americans were first to field a fifth-generation fighter, they are considered the favorites to win this race, with companies like Lockheed Martin and Northrop Grumman competing for the next-generation air dominance contract. However, despite the optimism, many believe the MiG-41 might never go beyond the planning stage, and this probably due to Russia's recent shortcomings. However, this country might just have a couple of tricks up its sleeves. Let's check out the features of some of Russia's formidable arsenals, starting with the Su-57. The Sukhoi Su-57 is a twin-engine stealth multi-role fighter aircraft developed by Sukhoi. It comes from the PAC-FA program, which started in 1999 as a more modern and affordable alternative to the MFI. Internally, Sukhoi calls the aircraft the T-50. This aircraft is the first Russian military aircraft designed with stealth technology and is meant to be the foundation for a family of stealth combat aircraft. This aircraft is capable of aerial combat in ground and maritime strikes. It features stealth, super maneuverability, super cruise, integrated avionics, and a large payload capacity. The Su-57 is set to replace the MiG-29 and Su-27 in the Russian military and is also being marketed for export. The first prototype flew in 2010, but the program faced long development delays due to structural and technical issues, including a crash that destroyed the first production aircraft before delivery. Despite these delays, the first Su-57 entered service with the Russian Aerospace Forces in December 2020. In designing this fighter jet, Sukhoi used the Lockheed Martin F-22 as a starting point for a super maneuverable stealth fighter, but aimed to address what they saw as limitations. These included the F-22's lack of thrust vectoring for roll and yaw moments, insufficient space for weapons bays between the engines, and difficulties in post-stall recovery if thrust vectoring failed. Sukhoi also believed the Raptor's design, focused heavily on air-to-air missiles, wasn't suitable for the multi-role needs of the PAC-FA program. The Su-57 features a wide blended wing-body fuselage with two widely spaced engines and all-moving horizontal and vertical stabilizers, with canted vertical stabilizers for stealth. Its trapezoid wings have leading-edge flaps, ailerons, and flaperons. The aircraft incorporates thrust vectoring and large leading-edge root extensions that shift the aerodynamic center forward, enhancing static instability and maneuverability. These extensions have adjustable leading-edge vortex controllers to manage vortices and improve high angle of attack behavior, including quick stall recovery if thrust vectoring fails. For air braking, the ailerons deflect up, flaperons deflect down, and the vertical stabilizers tow inward to increase drag. The aircraft's structure primarily uses aluminum and titanium alloys, but also extensively incorporates composites, which make up 22 to 26% of the structural weight and about 70% of the outer surface. Designed from the start as a multi-role aircraft, the Su-57 has a large internal payload capacity for carrying multiple large air-to-surface weapons. These weapons are stored in two main bays, between the widely spaced engines and smaller side bays near the wing roots. Internal storage reduces drag from external weapons and maintains stealth while improving performance. Its design includes a high degree of static instability in pitch and yaw, an advanced KSU-50 flight control system, and canted thrust vectoring nozzles, making it highly maneuverable and resistant to departures from controlled flight. It can perform high-angle maneuvers like the Pugachev's Cobra and in the Bell maneuver, and can do flat rotations with minimal altitude loss. The aerodynamics and engines allow it to reach speeds of Mach 2 and cruise supersonically without afterburners at Mach 1.3, giving it a significant performance advantage and extending the range of its missiles and bombs. With a high fuel load, the Su-57 has a supersonic range of over 1,500 kilometers, more than twice that of the Su-27. It also has an extendable refueling probe to further increase its range. The Su-57 is the first Russian military aircraft to focus on stealth, using various techniques to reduce its radar signature. Like other stealth fighters such as the F-22, it aligns the edges of its design to lower its radar cross-section. The edges of the wings, control surfaces, and the serrated edges of skin panels are carefully angled to minimize radar reflections. Weapons are stored internally, and antennas are recessed to maintain the stealthy shape. The aircraft is also coated with radar-absorbent material to absorb radar emissions and reduce reflections. The infrared search and track sensor is turned backwards when not in use and coated with RAM. To hide the engine's radar signature, the inlet ducts are coated with RAM, and the duct's partial serpentine shape hides most of the engine's compressor face and inlet guide vanes. A slanted blocker grid is placed in front of the IGV to further reduce visibility, similar to the method used on the Boeing F/A-18E/F. The aircraft's canopy is covered with metal oxide layers that are 70 to 90 nanometers thick, which improves radar wave absorption and decreases radar return from the cockpit by 30%, while also shielding the pilot from ultraviolet and thermal radiation. Production tolerances for this aircraft are much tighter than those of earlier Russian fighters to enhance stealth capabilities. The combined impact of the airframe design and radar-absorbent material is estimated to have reduced the aircraft's radar cross-section to about 1/30th of that of the Su-27. Sukhoi's patent for the T-50's stealth features aims to lower the average RCS to around 0.11 meters square, compared to the Su-27 RCS of about 10 to 15 meters square. The Su-57's design focuses on frontal stealth, with RCS-reducing features most prominent in the forward hemisphere. However, the rear fuselage is less optimized for radar stealth compared to American stealth aircraft like the F-22 and F-35, likely due to cost considerations and the Russian strategy of operating the aircraft within the protection of friendly integrated air defense systems. Like other stealth fighters, this aircraft is designed to be less visible to high-frequency radars typically used on other aircraft. However, low-frequency radars, which are used in weather and early warning systems, can still detect the Su-57 more easily because of its size. These radars are also large, affected by interference, and less accurate. The Su-57 has two main internal weapon bays, each about 4.4 meters long and 0.9 meters wide, and two side weapon bays with triangular shapes under the fuselage near the wing roots. The main bays are equipped with two types of launchers by Vimpel, the UVKU-50L for missiles up to 300 kilograms, and the UVKU-50U for ordnance up to 700 kilograms. The side bays use VPU-50 launch rails. For air-to-air combat, this airfighter can carry 4 long-range missiles in the main bays and 2 short-range missiles in the side bays. The primary medium-range missile is the R-77M, an upgraded version of the R-77 with better guidance and propulsion. The short-range missile is the R-74M2, a refined version of the R-74 designed for internal storage. A new short-range missile, the KMD, is being developed to replace the R-74M2. For long-range targets, the Su-57 can carry the Izdali 810 missile, an advanced version of the R-37M, with 2 in each main bay, although the R-37M can also be carried externally. For attacking surface targets, this aircraft can carry either 250 kilograms or 500 kilograms precision-guided bombs in its main bays. It can also carry several types of missiles, including the K-38M air-to-ground missile, K-35U anti-ship missile, NOK-58 USHK anti-radiation missile, and Kg-69 cruise missile. When stealth isn't needed, the Su-57 can use its 6 external hardpoints to carry a variety of Russian tactical weapons. A new hypersonic missile similar to the K-47M2 Kinzhal is being developed for the Su-57, designed to fit inside the aircraft's main bays. It also has a 30mm autocannon mounted internally near the right wing's leading edge. It has an effective range of 800 meters against aerial targets and 1,800 meters against ground targets. With these capabilities and advanced features, it's no wonder the Su-57 is one of the most advanced aircraft and feared aircraft in the world. Let's check out one of Russia's formidable sea beasts, the Belgorod. This submarine, popularly known as Doomsday Submarine, is Russia's brand new 5th-generation submarine. It's the world's largest submarine in active use till date. It is often seen as a mothership because while most submarines serve as a launching platform for direct attacks, the Belgorod launches other independent crafts as well. These include their artificial intelligence-assisted nuclear torpedoes, underwater recon drones, and even other smaller submarines. This explains its title as the world's most dangerous underwater submarine. All of these systems are launched from the Belgorod and either return to it once their mission is complete or are recovered later by separate vessels that are operated by the 110 crew members on board the sub. This enormous nuclear submarine poses a real threat in the ocean. It is stealthy, almost undetectable, and yet it carries a thermonuclear weapon that could destroy an entire continent. It can lie on the seafloor for a whole year, waiting for the order to strike. The K-329 Belgorod is a modified version of the Russian nuclear submarine Oscar II class. The development of this submarine began in July 1992 as a Project 949A cruise missile submarine, which NATO refers to as Oscar II class. This submarine is said to be the longest submarine in the world, 32 feet longer than the United States Ohio class, which are currently considered the most powerful subs on the Earth. The Russian ship wasn't made longer to set a record, but to accommodate the world's first nuclear-armed stealth torpedoes, as well as equipment for intelligence gathering. In addition, the thermonuclear torpedoes aren't just inside the submarine. They also float freely on the bottom of the seas and oceans, waiting for a command. Underneath the submarine is a special compartment through which repair drones can be launched to service these torpedoes. Some experts insist that these Poseidon torpedoes are capable of traveling hundreds of miles underwater and causing nuclear tsunamis. Both U.S. and Russian officials have reported that the torpedoes could deliver warheads weighing several megatons, setting off radioactive waves that would render long stretches of coastline uninhabitable for decades. That seems entirely possible for a 65-foot underwater rocket weighing 100 tons. Let's also check out one of the feared bomber in the world, Tu-160M bomber. This deadly aircraft is a variant of the Tu-160, also known as the White Swan or Blackjack. This technological marvel is one that possesses exceptional speed and enormous capacity. It was designed by the Tupolev Design Bureau in Russia during the early 1970s. In the world of aviation, this aircraft is renowned for being a powerful bomber that can carry nuclear weapons and other missiles. It is also the biggest and heaviest supersonic military aircraft that has ever been created, and its ability to fly faster than twice the speed of sound has made it exceptional. Interestingly, its wings can change their shape during flight. The Russian Air Force still uses it for long-range missions till date. The Tu-160 has been fully operational since the 1980s as a strategic bomber for the Soviet Air Forces and was built to serve as a conventional and nuclear-capable strike aircraft. The basic design includes wings that can change shape during flight and also a computerized control system that manages its wings. It also has flaps and slats to help with its takeoff and landing process, and its tail is shaped like a cross. About 30% of the aircraft's weight comes from titanium, with the biggest part being the hinge for the swing wings, which weighs about 6 tons. The aircraft is operated by a crew of 4 people, each seated in ejection seats for safety. Now to its propulsion system. This bomber is powered by 4 Kuznetsov NK-32 engines, and these engines were considered to be the most powerful engines ever used in a combat aircraft. When it comes to speed, unlike the American B-1 Lancer, which reduced its original requirement for speed to make it less visible to radar, the Tu-160 still has variable intake ramps and can reach speeds up to Mach 2.05. It has a system for refueling when it is flying for long-distance missions, although this feature is not often used. However, the bomber can hold up to 130 tons of fuel inside. In a training exercise that took place on February 2008, Tu-160 bombers, along with Il-78 refueling tankers, practiced mid-air refueling alongside other Russian combat aircraft like the MiG-31 and A-50. Radars equipped on an aircraft are very important in targeting threats, and for this reason, the bomber is equipped with a TS&PO Leninets Obzor K radar, known as Survey in NATO. This technology is used for tracking both ground and air targets. It also has a separate Sopka radar for following terrain closely. However, despite the Tu-160 being designed to be less visible to radar and infrared detection, it's not considered a stealth aircraft. Now, to its weapon-carrying capacity, the bomber can carry weapons in 2 internal bays. Each bay is capable of holding up to 20,000 kilograms of freefall weapons or a rotary launcher for missiles. These missiles can carry either conventional or nuclear warheads. It can also carry additional missiles externally if needed. The total capacity for weapons on the aircraft is 40,000 kilograms. With these weapons in its arsenal, it's no surprise wonder Russia is considered to be one of the most powerful countries in the world. Thanks for watching. While you are still here, click on the link on your screen to check out another of our videos. See you there.